this. Still, if you have any issues, any doubts or anything, you can always reach out to me. We can have, I can wait and help you to understand things in much better way. Okay. So these are all. Till this, I believe we have discussed in the last session. Maybe we are talking about data types, I believe. So we'll continue from here, from data types thing. And today, I think we have say, our Eclipse set up, right? We have set up our Eclipse and we are ready with Eclipse. So now we don't have issues. That we are good with that. Okay, today we'll complete all this, all the basic things. So when you talk about data types, so in Java we can categorize data types into two types: primitive and non-primitive. Again, under primitive we have again numeric data types and character data types. If you remember from last class, character is again divided into single character and string type. Okay, so again, non-primitive means these strings and arrays, all this. Again, numeric is divided into integer and floating. And to declare character, we use this char keyword. And then to declare boolean, we use boolean itself. To declare integer, we use byte, short, long, and int. We have discussed all this, and we have a detailed analysis. And we have seen few examples on this on Friday. And floating point, we use data types float and double. And non-primitive, we use a class. It's not strings, but it is a string we use here. So we have seen all this in the last session. If you remember, just a minute, let me open Eclipse as well. It should be open if I'm not wrong. So let me just open it. I think we have this. We were just checking on this, how to declare each data type. If you remember, I spoke about the suffix thing as well, right? I had discussed till this float example in the last session. Similarly, if you want to declare any string or any boolean, we just need to use boolean data type, simply speaking. We'll do one program with all these data types, all in one program, all data types with one program. So for boolean, you can say something like some bool equal to some true or false. Okay. And here, this boolean value has to be completely lowercase. This true or false should be lowercase. If it is Python, the starting letter of this true or false is uppercase, but in Java, this has to be true. Okay. And then, of course, what shall we do now? We have to print this. What shall we say? Just print it. Print bool. Let's print. What shall we do? Bool, and then you can run it in multiple ways. Right click, then run as your Java application. Now you should see true here. Again, let me run it. You can see here, right? So you are seeing true, right? So this is how you should declare a Boolean value. Similarly, suppose if you want to declare a string, I'm just showing you how to declare, each data type in Java. So suppose if I should declare a string, simply speaking, instead of this Boolean, just take a string. String has to be in double quotes. So what shall you do here? Some ABC, and then some stuff bool, you can say str, and then print str here. And if you see string is in what? String is in double quotes, and then run this, run as Java application. You can see string here. Now let's do one quick program for all this different, what shall we say, data types. Are you ready for this now? To demonstrate all the data types in Java, you can just create a quick program with a couple of, this thing. So we'll start with char ch equal to in single quotes sum a. This is a character value and with semicolon. And byte b equal to some 10. And then short s equal to some 20. So these are all simple things, right? So We have seen this in the last session. We are following blindly following data type syntax. Data type space var name equal to value byte short in some x equal to some 100, and then long some y equal to some 2000. So usually long is used for very big values, okay, to calculate lengthy values. Okay, but anyhow, just for testing, we can use like this. We can take simple values. We don't have a problem. Then we have declared a character, integer, and then string, and then one more is we just need to declare a boolean type. So boolean b equal to some true. You can test it along with me parallelly, just to have a quick idea how to use different data types in Java. Okay, so you can try this, and still, if you have any confusion, you can also ask me once the at the end of this session. Okay. So that's all about all this. Now, what you can do, you can print all these values one by one. 1, 2, 3, 4, 5, 6, 7, and okay, no problem. We have to declare float and double, I believe. So float f equal to 10.5 something, 10.5 f suffix with small f or capital F for float. Double d equal to some 20.7. Okay. So no suffix for double. Now print all this one by one. So here character ch, I'm just directly printing, not adding any text here. You can say the char value is something like this. If you want, you can add like this. This is Java, right? If you want to add any string with your value, you have to do concatenation. You should apply plus. You should separate your value with a string using plus here. Remember, okay? What is that you should do? Add plus between your string and your value. Okay, now what do you do right now? So here, copy this and print it a couple of times. I'm just showing you how to declare all different data types in one program. Okay, so print this one by one. So so just print. So now char ch and then byte b and then short s and then int x long y, then float f and then double d and then string str, and then one more is boolean b or bol. I'll just change this to bool because we have b already declared for byte. So changing this to bool, that will be a redeclaration. We cannot declare same variable for two times. Okay, so that's it. And change this the char value instead of char, just change this. So the byte, the short, okay, the int, the long, and then the float. You can try parallel along with me. That gives you more clarity for you. The double, okay, and then the string, and then the boolean. So like this. Now you can run this program. Just you can run it in multiple ways. And now I am clicking on this run button. You can see we got the output. So this is a quick idea how to test each data type in Java. Okay, friends, is this tested? So this will be with you. I'll share all this doc, even programs as well. I know. So that's about data types. Now, what is the next topic? Are you done now? All of you are good with this? Please confirm if you have done this. Please confirm if you have done this. Thank you. Thanks for confirming. Okay. If you have tested, please confirm. Sit. Okay, let's continue to the next topic. Yes, thank you. Thanks for confirming. Next one. This is all about data types. Now, this is about the data type summary. So this is the data we can see here and the keyword. For character it is char, for byte it is byte, for short it is short, for integer it is int. This is data and these are all data types or keywords. For float it is 4, for long it is long, for double it is double, for boolean it is boolean. And these are sizes. So for char it is what shall we say? This is size of char is 2 bytes or 2 bytes means 16 bits. And five, right, for each byte we have 8 bits. Bitwise size is 2 bytes. For byte it is 1 byte. For short it is 2 bytes. For int it is 4 bytes. For float it is 4 bytes. For long it is 8 bytes. For double it is 8 bytes. For boolean it is not applicable because it is true or false. And these are the ranges. What is the minimum value? What is the max value? So here if you see, character is unsigned data type. Unsigned means it accepts only positive values. Internally, every character you assign gets converted to an integer value. So that's why the range of char, if you see, it is 0 to 65,535. It is unsigned. It accepts only positive values. That is one thing. Second thing is apart from accepting positive values, the range, if you see, it is only positive, starts with 0, ends with 65,535. And one more important point is every character you assign in the program, it gets converted to integer. If you see the range, by looking at the range itself, you can easily understand. Now, next one, for byte, the range is minus 128 to 127. For integer, the range for short it is minus 32,768 to 32,767. For integer, it is 2e31 to 2e31 minus 1. E31 means 10 to the power of 31. Okay, you buy and you can calculate according to that. For float, it is 1.4e minus 45 to 3.4e plus 38. And for long, it is 2 minus 2e63 to 2e63 minus 1. Okay. And then for double, it is 4.9e minus 324 to 1.e plus 308. And for Boolean, the min is false, max is true. So these are all, this is a simple summary. So just remember this ranges. Okay, this is also important to remember. But anyhow, it's not like, you have to be perfect with all this. If you forget, nothing happens. Just Google it and just a quick idea. There will be a start range and end range for each data type. Got it, friends? So just remember that. What is the start and what is the end? Sometimes you need to have some clear understanding about these data types. Understood? Right. Next one about operators. I'm moving to the switching to the next topic. But before that, you need to have a quick idea about type conversion. What is that? So we need a quick understanding about something called as what shall I say? Let me just show you here type conversion. Okay, this is the topic. type conversion or typecasting. If you see here, the process of what is type conversion? This is important, very important to understand. Okay. The process of converting one data type to another data type is known as type conversion. And we have two types of type conversions. So if you want to convert one data type to another data type, so then we do it in two ways. One is implicit conversion, the other one is explicit conversion. Implicit conversion means automatic conversion. You don't need to do anything. Suppose if you see here, the value of byte can be easily promoted to int, but the reverse is not that easy for us. But reverse won't happen easily. You got it, friends? So that int cannot be converted to byte. That won't be allowed in Java because converting byte to int is called widening, and converting int to byte is narrowing. Java supports widening, but it doesn't support narrowing because in widening we don't have any loss of any extra bits, but in narrowing we have loss of some extra bits. So that's why it's easy to convert byte to int or byte to short, byte to long, byte to float, byte to double. Of course, we cannot convert byte to string or we cannot convert byte to boolean because of they are not compatible types. So while doing conversion, conversion happens to compatible types again, convertible types, not unconvertible types. Remember again, if you ask me that we have to do it in a different way. If you want to convert byte to string means yes, we can do conversion, but it's not a straightforward way like how you are doing like this. We have to apply certain methods and then we have to convert. Yes, we can do conversion, but not directly. Okay. So now this is a quick idea about what is that, what is type conversion and how many types of type conversions are there. What is implicit? Implicit means automatic conversion. Usually widening is automatic conversion. I'll give a clear picture. So it's not like we just stop there. If you see here, I'm taking another example of new and then class. I'll just name this as the name of class itself. I give it as type conversion. Okay, you can see here, I'm following strict naming standard here. And here it will be of two types, right? So simple. Of course, this statement is not 100% correct. As per sizes, you know the sizes, right? So in Java, this is not 100, the statement just to give you a quick, simple understanding, but this is not 100% right. Again, technically, this is not valid. So in Java, we can convert simple statement. Easy. Convert small data types to bigger ones. Data types to bigger ones. But not opposite. But not bigger ones to smaller ones. Bigger ones to smaller ones. This is simple idea. Okay, a quick idea. This is not technically valid statement. This is only just to give you a quick understanding. So we can convert small data types to bigger data types. But vice versa is not automatically possible. So here small data types to bigger data types. Let me just add data types to be more clear. But not bigger data types to smaller one. What do you mean by that? This is a very important topic. Okay, very important topic. So understand it carefully. So now if you see here, bigger data type to small data type. For example, except this is not applicable for int to float conversion. Even though int and float are same, so these two won't work for us. We can convert into to float, but we cannot convert float to int. I'll talk about it. Here now let's take the examples. So you take anything. You can convert byte to short or int or long or float or double. Of course, leave about string and boolean. They are different types, so we don't need to care about it. Again, short can be converted to all these types. We cannot, short cannot be converted to byte, but short can be converted to, so all this. Again, int can be converted to all this. But float cannot be converted to, we can, if it is float. So if you see here, float, we cannot convert float to int. This is not possible. So we can convert float to double. Long we'll check, not an issue. Okay, we can check this. Similarly, reverse is not possible. This right side one, we cannot convert back to byte. Automatic conversion is not applicable, for bigger data types to smaller ones. But you can explicitly do that. Sometimes, if the value is within the range of those data types, then we can do the conversion. So these statements again you have questions. What is the value is within this range? What is that you are trying to tell us? I'll give clear examples so that you don't need to get confused with anything. So when this conversion should happen, if you are is implicit conversion possible, or if not, can we go for explicit conversion? When this explicit conversion is possible, okay, you have to understand all this stuff. Okay, so here I have clearly given you the possible conversions. So byte, you know the size of byte, and then you can convert it to all these steps. But the reverse is not possible. Okay. Okay. Next one. I will take an example of this thing. Let's take the example of float. Let's see if this can be converted. I have a small doubt here. Some float x equal to 10.5 f. Okay. I'm trying to convert. How do you convert to other type in simple? Take long, some L equal to F. Simply speaking, just assign this float variable to this long variable. So I'm trying to convert float, and you can see an error here. What is the type mismatch? Cannot convert from float to long. Even this conversion is not possible. So this is one place where this conversion fails. Where this statement is not applicable. What is that? Long is 8 bytes, float is 4 bytes. Still, if I assign float value to the long, we are not able to convert. Why? Because float is decimal type, whereas long is int type. So both are not compatible. In that way, your compiler is not allowing to do this conversion because float might lose that extra precision. If you convert to integer, this is a decimal. These four data types, byte, short, int, and long, are integer data types. They don't accept precision or fraction. So when we convert float to long, that fraction is removed. That's why your compiler is cautious. It is saying this is not convertible. Why? Because if you try to convert float to long, there might be a loss of extra precision here. To avoid this, this conversion is not allowed in Java. That's why there are few cases this statement doesn't work. So this is one such case. Okay, so what is that case? This is the case where it is not possible to convert a smaller data types to the bigger one because due to the precision issues. So this is fine. Then you come up with a question. So implicit conversion means, let me just show you now before I go to this. Okay, so you take byte, some b equal to some 10, and I want to convert this to integer. You take int some x equal to 10. Now here, the value of byte, which is 10, usually the range of byte is minus 128 to plus 128, and 10 is the value of byte now. So is this 10 within the range of integer? Obviously, integer has a bigger range, so both are within the range. So you can happily convert byte to int here. So you don't need to do any explicit conversion. Got it right? No explicit conversion is needed because this value is within the byte value is within range of int. So this gets automatically promoted from byte to int here. This is implicit conversion. Okay. So system.out.println, if you just print X, you know, if you want, you can print byte as well. I'm just showing for of the converted value. When you run it, you can see 10 is printed, which is a byte. Sorry, I think I have to say X equal to B. This is the, if I just assign X equal to 10, it doesn't have any meaning. So assign your byte variable to integer variable. Then this byte get promoted to integer. While assigning the value of byte to int, what happens? This byte is promoted to int and then that is assigned to integer variable. So byte is not assigned to int as is. There happens a conversion. It's like, a poor boy marrying a rich girl, simply speaking. What happens? That rich girl's dad will give a lot of money to the poor boy. Assume that. I am not just saying it happens all the time. Just a quick example to understand. Voluntarily, if someone is rich, automatically boy is poor, but he is talented. Assume that. What happens? That rich girl's father, what he will do? He will give so much of money to that boy and gifts to that boy and make sure that he is to his level. So then the marriage happens. Same thing here. What is that? We are promoting byte to int here. So in that process, first this byte is promoted to integer level, and then that value is assigned to the integer. It's like poor by once getting rich and then marrying a rich girl. Got it right? And both are at the same level. Earlier this is poor, this is rich. Now, because of marriage, which is type conversion, what happened? That byte is promoted to int level and that is assigned to this integer. But this happened automatically, arranged marriage. Okay, so automatic conversion, no issues. But there is another one. What is that? Just, you can laugh if you feel like laughing. I don't know if it make any fun. Okay. So, second one, the other opposite, love marriage. So, float is a different type, long is a different type, but we need a conversion. But possibly there is some loss of data. Suppose here now again opposite. What is that? Sometimes this is not allowed, right? When you are losing something, you don't allow to do that. So that is compiler, our father or mother. What is that? Compiler is saying, don't do this conversion. There might be cause of loss of data, but still we want the conversion. Then we go for explicit conversion. So what happens here? In this case, you go out somewhere and do some registered marriage, explicit conversion. So what do you do right now? If compiler is not allowing this conversion, and still if you need that conversion, because just we are both are numeric type, converting to numeric is not a big issue because we can convert float to int, no problem. But we might lose this precision. If you don't care about precision, you can go for that conversion. So what do you need to do if compiler is not accepting implicitly? Just you need to apply typecasting. What is that you should do here? You need to apply something called here. If you see here, you need to apply. So programmatically is known as, so converting one data type to another data type programmatically. And this programmatic conversion, you call it as typecasting. And the syntax look like this. Anyhow, I'll give you a quick, easy understanding here itself. Now, float has to be converted to long. What should you do? Any data type, just remember, conversion has to be done to the long type. So, before this float variable, you just put this long data type. Now, float has to be converted to the long explicitly, programmatically. So what do you do right now? We got this error because X is already there. You can put some Y or Z or something. Okay, float Y. And now you do the conversion. Okay. So now this is explicit conversion. This is not love marriage. This is love marriage. Compiler is not accepting. So parents are not accepting. Still conversion is needed. So you do it explicitly. So how do you do that? By applying something called typecasting. It is a very simple thing. Whatever the data type to whichever the data type you want to convert, just put that data type before that variable. Then automatically that whichever the variable you want to convert, that gets converted to the data type You are just adding that before that variable. You are keeping before that variable. So this is typecasting. You can do this for anything. Suppose you want to convert some int to byte. So what do you have to do? Same thing. Suppose I'll take one more example. Let's take an example of some int, some what shall I say? A1 equal to 10. But this has to be within the range of byte. If I should convert into to byte, the integer value should be within minus 128 to plus 127. Okay, otherwise you get again some kind of bit compression. So this is a bigger data type. Now I want to convert to smaller data type. This is not automatically possible, but we can do this by type conversion. So what do you do now? You take byte some b equal to some a1. Do you think this is allowed? I don't think. Maybe you take b1. B is already there. So this is not automatically allowed. You can see an error here. Read the error. What is the error? Type mismatch. Cannot convert from int to byte. Poor. This rich boy int cannot be converted to poor by byte. But still we need conversion. Right? What shall we do now? So we have to apply typecasting. To which data type you want to convert this int? I want convert int to byte. Then before this variable a1, put this data type, blindly add this byte. This is clearly saying to the compiler, I know what I am doing. You please ignore and do this operation. That is the meaning of this explicit conversion. Now I have converted this int to byte. So automatically this int gets converted to byte. Now if you print this value, see here, you can print system.out.println of L. You can print here. If you want, you can print all those. It's up to you. I'm just only showing you how to do this and then B1, right? And then run this program and you can see the values. And here, especially, so particularly you have to observe this case. Here, earlier the value of float is 10.5. After you do this conversion, this float got converted to 10 only. We lost that precision. We lost that extra bytes. That's what happens when you try to convert decimal to integer. But generally, decimal to integer conversion is not possible automatically, but we can do it explicitly, but at the cost of losing that extra precision. Got it, friends? I hope you should be clear with all this. All of you are clear here, friends. So this is a quick idea about type conversion and types of type conversion, implicit and explicit, and how what is the syntax of typecasting. Now, if you see the syntax, this is the syntax. What is syntax? Data type, some that variable name equal to that type you need to convert and then variable two. And here this data type and this data type are same because var2 should get converted to this var1 data type. So the same data type before var1 you put before var. That's all. So just a quick clarity here, quick idea. This is a idea about type conversion, one of the very important concept in most of these traditional languages. Okay, even this is there in Python, but that is done a different way. Okay, right. This is a quick idea about this one. Next one. Let's move to the next topic. What is that next topic? Operators. We'll quickly go through operators. So these are all operators in Java. So what is that arithmetic? Let me just show you. You can see here, friends. These are all binary operators. In that, the very important are arithmetic, plus, minus, into, slash, and percentile. We don't have too many operators here, just five arithmetic operators. Slash is for division, percentile is for remainder. Okay, and relational, less than, greater than, less than or equal to, greater than or equal to, not equal to. That's all. That's relational. Logical, and, or, and not. Bitwise, and, or, less than double. I mean, this is a left shift operator, right shift operator, and then this tilde operation means flip operation, and then this is not operation. Okay. And assignment equal, plus equal, minus equal, something like this. This is assignment. Ternary colon, question mark colon is ternary. Okay, and then what shall I say? Finally, unary operators, plus plus and minus minus. Okay, this is all about operators, friends. Understood, no? So this is all about different operators. So let's check this with some examples. This operator concept, why don't we check with few examples? Are you ready for this now? So before that, are you clear with this type conversion concept? Are you clear with this type conversion concept? Thanks for confirming. So are simple. I don't think it's too difficult to understand operators. Okay. So here, so these are all these things. Okay. I hope you got clarity. We'll talk one by one here. Arithmetic operators: addition, subtraction, multiplication, division, and percentile. This gives reminder. So whatever we have here, so this is going to give you a reminder. What do you do, right? You can test this program, and slash gives this gives quotient, and this gives reminder. Okay, let's quickly do a quick program here for to test this arithmetic operators. New, you can also, just a minute. Okay, now right click, new class, Aritops. I just take the class name is Aritops and then click on finish. Just take main inside this. Okay, and then add two variables, anything of your choice. Int a equal to 10, b equal to 5. Now you can test this all arithmetic operations, a plus b. If you want, you can use resultant variable. Assign your result to the third variable and print it, something like this. You can assign the value of this one, addition to some c equal to a plus b. Okay, then that result is stored in C, and if you just print that as C, that would be enough for us. What is that? This is also valid. This is how usually we do. Okay, the addition is the sum is okay plus, put plus C, something like this. Similarly, you can try for all different operations. What is that? We did for addition. Similarly, try for, okay, I forget to add data type. That's all. And then I forget to add data type for C also. You need data type for each variable in these typed languages are static data types. Static typed languages. Okay. Every variable has to be declared. Otherwise, we get variable not defined, something like that. Okay. So again, C equal to A minus B. If you want, you can choose a different variable. It's not like it should be C always. You can take some other variable as well. But for my convenience, I'm just using like this. We can do programs in multiple ways. Okay, it's not just one way. So we can declare all logics at one place and print them using multiple variables. I'm just using this reusing the same variable because I'm printing it immediately, and later on I'm dumping that value, and then again I am assigning some other result to that. So I don't need multiple variables to store the result. This is only just to demonstrate this arithmetic, right? The sum is, so the difference is, similarly maybe you can copy again and then just change that. I'm not showing everything, but Even it doesn't take much time. Anyhow, we are already doing right. So you can quickly check this on all the arithmetic. You can also try along with me. So like this, A minus B, A into B, and then A slash B, A percentile B. So that's all. We don't have more. And now what do you do? Here, just change your strings. Change your this thing. So the mul is, and then the quotient is, and the remainder is. Just add this. Make sure your strings are clear. So these are all output strings I have added. Now, only thing you might be having a little doubt with this slash operator. Percentile gives remainder, slash gives quotient. What happens here? Simple, friends. Let me just show you if I have any. Yeah, let me just explain here itself. Okay, just a minute. So if you see here, the value of what is that? Mm, Let me take this. Take this. The value of is 10, and we are dividing with 5. 5 to 10. Okay, what do we get? Remainder 0. Now, this is a quick division we are doing. When you divide this, when you say slash, it gives quotient. What is the quotient here? That is 2. So here we get 2. And here, if you apply percentile, it takes remainder. What is the remainder here? We get 0. So when you run this program, now what you can do, you can clear all annotations and then you can just run this program. So slash gives quotient. Understood, right? It does division, but it gives quotient, this part. Percentile, it does division, but it takes remainder, this part. That is a quick idea. I hope this should be clear for all of you. Okay, so I'm deleting this annotations and then executing the program. Just what shall I do now? I should exit this. Okay, we are done, buddy. Don't need this anymore. Okay. I should remove this now. Where is this option to remove? Just a minute, friend. Sorry, I think somewhere I lost this. Let me just close this. It's not getting close. Okay. Okay, let's. So when you run this, what happens? You get these outputs, but somehow this got stuck here. What shall we do now? We can somehow. Yeah. Now, yes. Okay. This got hidden actually. I was looking for this quite some time. Sorry for for missing out on this. Thank you. So let's continue now. You got it right. Go to the this one and then run this. You can see the output. So as discussed, we got perfect output here. This is all idea about how to write a simple program for arithmetic operators. Similarly, you have relational. So what is that? We have this relational operators here. Let's just see this now. Here, if you see, these are all. So this is for demonstrating arithmetic. So to test relational, you can take this example. Okay, let us see this. This is assignment. Okay, I'll talk about it. This is relational. Okay, how do you test it? Simple. You can test in multiple ways. We can quickly change this. So here, right click and then new and then class. You can test it like this. Relational ops. Okay, finish. And then put main in this. Just test all those relational operators. What relational operators does? It compare two or more values and returns a Boolean result. So we'll just see here. You get it. It's so simple. Int a equal to 10 again. If you want, you can declare two variables like this. Int a equal to 10 comma b equal to 20 or b equal to some 5, something like this. If you want, you can also declare multiple variables with one data type in the same line. This is also possible. So, but for me, the most recommended one is this. I just go for declaring each variable separately. This is the recommended standard approach we do in programming. Okay. So now system.out.println a greater than b. So greater than, you know what it does? It checks whether a is bigger than b or not. And then if it is true, it returns Boolean. Else it returns if it is valid. So if it is true, you get output as true. If it is false, you get output as false. That's it. So this is so simple to understand. All this, we'll finish up these things today. So tomorrow we'll go up with the control statements. So if you can cover these control statements in tomorrow and day after tomorrow's session, it would be much more easier for us. Okay. We'll make sure we are understanding everything clearly. And you can also parallelly give a try along with me. You have sufficient time while I'm doing. So you can try this. And still, again, I'm saying, if you have issues, you can stay back, we will discuss. Not equal to B. And even after that, still you have issues, you have this recording, so you can try from this as well. So this is a quick idea to demonstrate relational operators. A greater than B, A less than B, greater than or equal, less than or equal, not equal. So you know the answers here, right? What do we get here? If it is A greater than B, it is true. 10 greater than 5 is true. The output is true. Here it is false. Why false? 10 less than 5. Anybody knows this. Even a third standard school kid can answer this quickly. So A greater than or equal to B, this is true, right? It might not, equality might fail, but greater than is true. So that's why we get true. And this obviously is false without any second thought. And this one is, what is this? This is not at all true because 10 and 5 will never be same. Okay, right? And then not equal to this, even 10 not equal to 5. This is pretty true. Why? 10 not equal to 5 is true. So this is true. So you just need to analyze your outputs like this. Go to this and run this. You can see here, you got the outputs. Okay. True, false, true, false, false, and then true. This is perfect. So this is idea about what, friends? Idea about relational operators. Then what else we should do? Next one, maybe quickly we can check on. I don't know what is time now. What's time? Let me just see. Are we? Okay, we are almost at the end of this. No problem. Right? We'll complete this and stop this session. Relational is over. Logical, and then we have few more. Okay, we'll do thing. We'll do one thing. Then we'll switch this topic to tomorrow. We'll complete this all these examples tomorrow, and then switch to the next topic. What is that? Control statements. And then we'll talk about functions and then OOP concepts, and then switch to again our Selenium setup again. So we'll go to the Selenium concept back because our focus is not on Java, but it's on Selenium. Only just to get a quick understanding about what we do, different things in Selenium, just having a quick touch up with this Java thing. Okay. Maybe we'll plan for one full-fledged Java session. So all these are free sessions only. Nowhere you need to pay. So we'll go through that. We'll stop here. We'll continue tomorrow on this stuff so that you know everybody can start for offices. Thank you. Any questions? You can stay back. Any help needed or any doubts? You can stay back. I'm just opening the chart now. I mean the mic thing. I'm enabling mic. So if you wish to ask any questions, so what you can do, uh, we can discuss just for a few minutes. Any questions? All of you are good? Then no issues. If you don't have questions, then we are good. Yep, thank you. So then we'll catch up tomorrow. As I told, right? Thank you.